Hi guys, welcome back. We are going to talk about something called surface area today, and we are going to find surface area of all different three-dimensional shapes in this unit. But today what we're going to do is we're going to focus on rectangular prisms. So I want you to think of a rectangular prism like a box. Okay, so I don't know about you, but I've been getting lots of Amazon packages in the mail during this quarantine. And so if you think about those boxes, whoever is creating these boxes needs to figure out how much cardboard is needed to make them. And so what they're really calculating is the surface area. So I want you to think of surface area as they're covering something. Okay, so when you wrap a present, you're covering whatever it is that you've purchased. And so you're trying to figure out how much wrapping paper do I need to cover that surface area. So anything where you're covering a three-dimensional object is considered surface area. And remember, area is a two-dimensional shape. How much space is inside a two-dimensional shape? Where surface area is how much area is needed to cover a three-dimensional shape. Okay, so that's the main difference between area and surface area, two-dimensional versus three-dimensional. So like I said, we're going to look at rectangular prisms today. So what is a rectangular prism? I said it was a box, but really what it means is that all of the faces, a face meaning a side, so all of the sides are rectangles. Okay, another type of rectangular prism is a cube, and this would be something where all of the faces or all of the sides are squares. Okay, so you guys all know what cubes are. Think about a die, a six-sided die. That's a cube. All of the sides, all the faces are squares. Okay, so in order to find the surface area of rectangular prisms, what we're going to do is we're going to find the area of each of the faces or each of the sides. And when we're done doing that, we'll add all the areas together and that will give us our surface area. Okay, so if you look at example 1, you can see that we have this rectangular prism where the length is 8, the width is 3, and the height is 6. So our job in order to find the surface area is to find the area of each of the faces, each of the sides. So any rectangular prism is going to have 6 sides. There's a top, a bottom, a front, a back, and a left and a right. The good news is any sides that are opposite, meaning the top and bottom, the left and the right, the front and the back, they will always have the same area. So really what you're doing is you're finding the area of 3 sides and then you're just doubling it, okay, which is kind of nice. So if you look at this, again, in example 1, the top, I'm going to shade in the top because I think that'll help you visualize the side that I'm talking about. Okay, so here's the top of that rectangular prism. And so because it's a rectangular prism, we know all the sides are rectangles. And to find the area of a rectangle, we're going to do area equals length times width. Okay, so for each face, we're doing length times width. So to find the area of the top, I need to figure out what is the length and what is the width. Well, because I know that this is 8, that means that this side is also 8. And because I know this is 3, I know that this side is also 3. So the area of the top would just be 8 times 3, or 24. Okay? So then the area of the bottom is the same. Okay, so the top and the bottom always have the same area. We can see that because here's the bottom. Okay, so that we can see is 8 by 3 also, which is 24. Okay, so now let's do the front and the back. I'm going to erase all this so we don't have any issues there. Okay, so the front of the box. Shade that in. So this is considered to be the front of our box. And again, it's a rectangle, so I'm going to do the length times the width. So I can see the length of the front is 8. What I don't have is the width, but I do know that this side is 6, which means so is this side. And so there's our length and width. So I'm going to do 8 times 6, which is 48. Okay, now the back has that same area. Let me show you the back just so that we're clear. So this is the back side here. Kind of plays a little trick on your eyes. So the back has the same length as the front. So this is 8. And we can see the width there is 6, which is what makes it the same. 8 by 6 is 48. All right, so the last two sides we have are the left and right. I'm actually going to do the right side first because here's the right side. I know the length and the width, 6 and 3. And I know that's the same as the left side, which is over here. So I can say both of those are 6 times 3, which is 18. Okay, so our last step is to add all of those areas together. Okay, so the surface area is the sum of all the areas of the faces. Okay, now you don't have to write that out every time. I'm just showing you so that you know what I'm adding. But when you add all 6 sides together, you should get 180. Now, for a label, it's still area, so we're going to use meters squared. Okay, so surface area is still area, so it's still in square units. All right, awesome. Now, you guys are going to love cubes because what do we know about cubes? We know all the faces are the same. All the faces are squares. Okay, so in this example here, we can see that every side has a length of 4. Okay, so if I start with the top, which is right here, it's a square. I know it doesn't look like it, but it is because we know it's a cube. So the area of a square is side squared. So the area of that top would be 4 by 4 because I know that this is 4 and I know this is 4. 4 times 4 is 16, which is the same as the area of the bottom, also 16. Okay, the front and the back. So here's my front, right? 4 by 4, 16. So you guys can see what I'm getting at here. We know the back is the same as the front, so 16. And then your right and left, I'll do the right first. 4 by 4 is 16. Okay, so what's really cool about cubes is that you really just need to find the area of one of the sides, one of the faces, and then you just add that together 6 times because all 6 faces have the same area. All right, so let's go ahead and add that 16 plus 16 plus 16 6 times, or you could just do 16 times 6. And you're going to get that the surface area is 96 centimeters squared. All right, let's go back and do another rectangular prism, so example 3. So we're going to start with the top. Remember, we're using length times width because in a rectangular prism, all of the faces are rectangles. So here's my top. The length and the width are right here, 4 times 2. Okay, the bottom is the same. To do any work for that. Okay, the front and the back. Here's the front. Okay, so I can see the length of the front is 7, but the width I have to use is 4 because those two sides are the same. So 7 times 4 is 28, and that's going to be the same as the back side. So another 28. All right, left and right. I'm going to choose to do the right because I can see the numbers here. So the right side has a length of 7 and a width of 2, which is 14. So that means the right side is also 14. Okay, so surface area. We're going to add all of those sides together. And we should get 100 meters squared. All right, awesome. Let's do one more cube here. So all of the sides have 2.1 as their length. So remember, if it's a cube, we're doing sides squared for each face. So if I look at the top, which is the same as the bottom, so I'm just going to do this, I can see that it's 2.1 times 2.1, which is 4.41. And like we saw in example 2, in a cube, all of the faces have the same area. So once you find one, don't hesitate to just show me. All the rest are the same. Okay, as long as you showed me how you got that 4.41 in the beginning, I'm okay with you guys writing that out. Okay, so I have to do 4.41 times 6, or add it together 6 times, and I should be getting 26.46 centimeters squared. All right, hopefully you guys are following along okay with that. So we're going to do 2 more, and what I would recommend is stopping the video here, seeing if you can get number 5 and 6 correct on your own. So stop it, try it, and then replay it, and you can watch my work and see if you get it correct. Okay? All right, so in these ones I didn't list out the 6 sides for you. So I'm just going to quickly write top, bottom, left, right. And by the way, it doesn't matter what order you do. If you started with left, right, front, back, no problem. As long as you find all 6, it doesn't matter what order you found them in. Okay, so the top and the bottom, I can see, right here's the bottom. So that's 3 by 4, which is 12. Okay, my left and right, I'm going to go with the left side here. So that side is 10 by 3, which is 30, same as the right. And then I'm going to do the front and the back. So I'm going to do the front here is 4 by 10, because this is also 10, which is 40. Okay, so if you did this one correctly, you added up all the sides, you should have gotten 164 yards squared. Okay. All right, let's see how you did with the cube. So remember, same thing for the cube, but what's kind of nice is that all of these sides are the same. So honestly, the thing that takes the longest is just writing all of these sides out. You guys can absolutely abbreviate too. T, B, L, R, F, B, and like that. Okay, so I didn't write this over here. We did length times width for this one. For this one, we're doing sides squared. So each side has a length of 9. So the area of every face is 9 times 9, which is 81. So all of our areas are 81. So 81 times 6 is going to give us 486 square inches. All right, so hopefully you guys got those 2. The last thing we're going to do is a couple word problems. Okay, so we might be doing some drawing here, some art class. So number 7 says, a dog food box has a length of 6 inches, a width of 8 inches, and a height of 15 inches. Find the amount of packaging material that will be needed to completely cover the box. Okay, so if you know how to draw 3-dimensional boxes, here's how I do it. So I start with kind of like the front face, okay, and I'm drawing it like this because it tells me that the height is 15, so I know it's going to be taller than it is wide. And then what I do is I draw another one kind of inside like that, and then I just connect my corners. That's my easy way of making a 3-dimensional box. Okay, so after you have your box drawn, I would definitely label. Okay, that's the whole point of drawing it. So it tells me the height is 15 inches. I'm going to label that 15. The length is 6 and the width is 8. Now, does it matter what I call the length and what I call the width? Absolutely not. So if you want to say that this is 6 and this is 8, or reverse, that one's 8, that one's 6, it really doesn't matter. Okay? It all will work out, trust me. All right, so let's go ahead. I'm going to abbreviate for this one. So top, bottom, left, right, front, back. Okay, so top and bottom. I can see those faces are 6 by 8, the top and the bottom. So that's going to be 48 for those two areas. The left and the right, I can see are 15 by 8. So 15 times 8 is 120. So those two have the same area. And then the front and the back, I will kind of highlight this one for you. So the front is right here. And if I know this is 15, so is this. Okay, so 6 by 15 is my front and back, which is 90. Okay, so let's add all those up. And we get 516. So find the amount of packaging material that will be needed to completely cover the box. 516 square inches of packaging material would be needed. You guys will notice if you have a roll of wrapping paper, that you've not opened yet, you'll see right on the outside of that wrapping paper, it tells you how many square inches or how many square feet that roll will cover. So next time you go to buy wrapping paper, you're in the store and you see some, check it out. Some rolls cover much more than others. It's interesting to see. This is definitely where it comes into play. All right, number 8, Ryan wants to wrap a gift that is a box measuring 11 by 11 by 11 centimeters. How much wrapping paper will he need? Okay, well, since we know the box has all 3 of the same dimensions, we know this must be a cube. Okay, so try my best to draw a cube here. All right, not too bad. So 11 by 11 by 11. So it means the length, the width, and the height are all 11 centimeters. Okay, so top, bottom, left, right, front, back. All right, so what do we know about cubes? We know all of the faces have the same area. So once I find the area of the top, all 6 faces are going to be that same number. All right, so I'm actually going to look at the bottom, just because in my picture it's easier to see that that square is going to be 11 by 11. 11 times 11 is 121, so the area of every side is 121. All right, so how much wrapping paper will he need? Let's see, we need to add up 121 6 times, or 121 times 6. And I'm going to get that I need 726 square centimeters of wrapping paper. All right, last one. Lacey uses 253.5 square inches of paper to cover a box in the shape of a cube. What are the lengths of the sides of the cube? Okay, so this is a little bit tricky. I know the surface area, right? They don't come out and say this is the surface area. They say this is how many square inches of paper we used to cover the box. So we have to know that that number that they gave us is representing the surface area. So I'm just going to write that here. And what they're asking us for is what the side lengths are if this is a cube. This box is a cube. Okay, so we kind of have to think backwards a little bit here. If I know that all 6 sides of my cube, all the areas of all 6 sides, were added together to get 253.5, could I figure out what the area of one side of that cube would be? Think about that. If I know all 6 sides together is 253.5, how do I find the area of one side? You would divide by 6, right? So if I take that surface area and I divide it by 6, that's going to tell me what the area of each side of that cube is. So if I divide, I get 42.25 inches squared. So again, that's the area of each side of my cube. Okay, now I'm not done because it doesn't want that. It wants to know what are the lengths of the sides of the cube. So let's think about if each side has an area of 42.25, how can I figure out what the lengths of the sides were? Well, to figure out the area of a square, which is what the sides of a cube is, you would have to say what number times itself gives me 42.25. Well, that sounds like a horrible thing to have to guess and check to figure out. And so one way that we can do this, and we did this with circles, is we can take the square root. The square root of a number tells me what times itself gave me that number. So if I take the square root of 42.25, I'm going to get 6.5. And so what that means is that each side of that cube must have been 6.5 inches. 6.5 times 6.5 gives me 42.25, and then I multiplied that number by 6 and got my surface area. So that's how you can kind of work backwards to check.